Hello, today I'm going to take you through inverse trig functions. So let's start off with the inverse to sine. Now we write out inverse trig functions like this. We either say arc sine is how we read that of 1/2, or the sine inverse of 1/2. Both of these mean the exact same thing, and you could see them written out either way. Now, what I'm asking for here is what angle makes the sine of x equal to 1/2? Or let me write that down. If I'm taking the sine of x, what value for x here makes this equal to 1/2? So I drew this circle out to remind us of the unit circle, and that's what we're going to think about on this. When is sine equal to 1/2? Well, it's equal to 1/2 right here and right here. Remember, we're thinking about those triangles that we did when we talked about the unit circle, and our y value is 1/2. So there are two spots from 0 to 2 pi where y equals 1/2. Right here at pi over 6, and then over here again at 5 pi over 6. So that becomes a problem, because this can't be a function, or this right here cannot be a function, if one x value is giving me two different y values. In fact, if we look at the graph of sine of x, what does that look like? Well, it looks like this right here. And notice if I were to draw a line at y equals 1/2, I get a whole lot of spots where this is true. So y equals 1/2 is right there. There are all these spots in here where the y value could be 1/2. In fact, if we kept going around this unit circle right here, if you add 2 pi to that, add 4 pi to it, I'd be going around twice. Remember, there are an infinite amount of coterminal angles to pi over 6. You just keep adding multiples of 2 pi. And so what we get here is there can't be an inverse this way, because there's a lot of different answers that I could put right here. And then therefore, I'm putting in one x value, and I'm getting multiple values here and for my inverse. And so it's not a function. Let's go back and look at the graph of this. And we've seen this before, this problem before, when we talked about the inverse to y equals x squared. So if I type in y equals x squared, I get this. And remember, if we looked at the square root, if I were to reflect this to get the inverse, you reflect it over y equals x, I would get this parabola lying on its side, and it wouldn't be a function because it wouldn't pass the vertical line test. So you need to recall what we said about this. We had to restrict the domain because the function was not 1-to-1. Remember, 1-to-1 means for every y value, there is only one x value that maps to it. Or maybe a graphical representation would be that it has to pass the horizontal line test so that when we reflect it over y equals x, it will pass the vertical line test. So looking back at that green parabola right here, we said, you know what, let's restrict this domain. Now let me turn off these other two in case that's confusing, seeing all that on at once. If we were to restrict this domain, we could have an inverse. So we said, okay, let x just be greater than 0. So we put in squiggly and say that x must be greater than 0. It could actually equal 0. Let's type that in then. Greater than or equal to 0. And then there you go. So we've restricted x squared, and now if we reflect it, we will get an inverse, and it does pass the horizontal line test. That's exactly what I need to do with my sine function here. And so here's the sine of x. I'm going to restrict it from negative pi over 2, which is right here, to pi over 2, which is right there. And that's what I've done here on the left. I'm going to say graph that. And that's what it looks like. It's highlighted right there. You could turn off the other function and kind of see what it looks like. Let me zoom in. So notice this one right here will pass the horizontal line test. So when I flip it, let me show you what it looks like when I flip it. That's flipped over y equals x. This is, notice, graphed arc sine, or sine inverse, however you want to put it. Notice now it passes the vertical line test. So it's a function. And so that's what we're going to do. Just like we restricted the domain for x squared, we're going to restrict the domain for sine. Now, what does that look like on the unit circle? And remember what I'm doing here. I'm going from negative pi over 2 to pi over 2. And so on the unit circle, it looks like this right here. Here's my unit circle. Ignore that. I went off the circle a little bit. Negative pi over 2 is right here. and pi over 2 is right here. So when I'm asking for arc sine or sine inverse, however you want to write it out, I'm looking for values just on this right half of the circle, from negative pi over 2 to pi over 2. Nothing, no angle bigger than pi over 2 and no angle less than negative pi over 2. And now when I ask this question, what is the arc sine of 1/2? You can say, well, 1/2 is right here at pi over 6. So the answer to this is pi over 6. Or if you look at it, if it's written out like this, same answer because it's the same question. It's pi over 6. And what this means is the sine of pi over 6 is equal to 1/2, and the sine inverse of 1/2 equals pi over 6. Remember what inverses do? They undo one another. And so when you undo that, they should be sending you, you can switch the x and y charts. All those things we talked about, inverses, apply here. All right, but we do have to restrict the domain. One more thing I'd like to show you is just how this looks like on Desmos when we graph them right on top of one another. So I'm going to graph arc sine in here. Arc sine of x. There it is. And so that's what it looks like when they're graphed together. And remember, this should look like a reflection over the line y equals x. Now let's make that a dashed line. There you go. And zoom out a little bit, and we can see that they are reflected over y equals x. That's zoomed out too much. Go back in. I think you get the point. I don't want to. Sometimes Desmos gets funny when I start zooming in and zooming out using Control plus and minus. But that just kind of shows you how they're reflected there. So once again, let's go back and just kind of state that out again. When we're talking about this, it has to be between negative pi over 2 and pi over 2. And we'll see that through our examples. Now let's take a look at the same problem, but instead of arc sine, let's look at arc cosine. So when does arc cosine, or when does cosine equal 1/2? That's what I want you to think about. Well, remember, cosine on our unit circle is our x value. So cosine is 1/2 here and here. Draw our line going straight up. This is our x value of 1/2. Actually, it's not 1/2 right there. It's negative 1/2, right? So it's okay for it to be over in there. We'll see that in a second. So it's right here and here. So this is at pi over 3. And this is at 5 pi over 3. So once again, if we're talking about between 0 and 2 pi, there are two locations, that give me 1/2 for the cosine. Cosine of pi over 3 is 1/2, and so is the cosine of 5 pi over 3. So just like with sine, we're going to have to restrict our domain. And remember, cosine curve looks a lot like sine curve, so we know already it's not 1-to-1. We've got to restrict the domain. But this time, we're not going to restrict the domain to the right half of the circle. If we look back at sine, restricting it to just the right half doesn't make any sense because we got two possible answers here on the right half. Instead, what I'm going to do is restrict it from 0 to pi. So now we're going to restrict it on the top half of the circle. And look at what that does. That gives me positive x values here and negative x values right there. And so we cover everything we need to for cosine when we do that. So when is cosine equal to 1/2? It's equal to 1/2 at pi over 3. Or if you said the cosine inverse of 1/2, it's there at pi over 3 because it's the same question. So for cosine values, when we're talking about arc cosine or cosine inverse, we're only talking about the values from 0 to pi. One more to look at here. Let's look at the tangent. Now, I didn't say the tangent of 1/2 because that is not a common answer when we're talking about the unit circle and when does tangent equal to 1/2. One spot we could say is square root of 3. When does the tangent equal square root of 3? So remember that tangent is our slope. That's how I taught it. If you haven't seen that video, go back and watch my video on finding the tangent on the unit circle. But if you think about it as slope, there are two spots where it could equal that slope of square root of 3. Right here and right here. Remember, it's the steeper slope. So this is at pi over 3, and this is at 4 pi over 3. So once again, we run into that problem where there are two locations where tangent could be equal to square root of 3. So we're again going to restrict it to the right half of the circle. And now notice there's only one location where tangent could be pi over 3, and that is, square root of 3, and that is at pi over 3. And so we get the same value here for both of these. Let's write all these rules out so that they're summed up before we start tackling some problems. Boom, there you go. So this says that for negative pi over 2 to pi over 2, for y values between or equal to those values, then y can equal the arc sine of x if and only if, remember that's not a typo or a misspelling, IFF means if and only if. The only case this can be true is if x equals the sine of y. This is a fancy way of saying that we're only taking the arc sine if we're restricting the domain. All right, and this restriction has to be between negative pi over 2 to pi over 2. What we just did, we're just kind of summing it all up. We're just talking about the right half of the circle. Remember, negative x values go clockwise and positive radian measures, that is, go counterclockwise. We're not going to take anything bigger over pi over 2, and we're going to see that in our examples. This one, for y values between 0 and pi or equal to those, we can take the cosine or the arc cosine of that. And so we're restricting that from the top half of the circle, from 0 to pi. We're talking about these values. And then lastly, for tangent, we restricted it to the right half again. But notice the difference. I want you to see if you can notice the difference between tangent and sine as far as the restriction goes. They are both the right half of the circle, but look at the symbols here. That is greater than, or y is greater than negative pi over 2, and here y is less than pi over 2. Up here you've got the bar underneath. So remember that the tangent value at pi over 2 is undefined, so you can't take the arc sine, or the arc tangent of undefined. It's not a number, it doesn't make any sense. So we're not including pi over 2 and negative pi over 2, but everything else in the right half of the circle is okay. Here we can take the arc sine of pi over 2. That's fine. But we can't take it down here. All right. Sorry, not the arc sine of pi over 2, but the arc sine of 1 gives you pi over 2. So it's fine if we leave that in there. Sometimes I start talking and I don't think about what I'm saying. That's not a good thing, is it? All right, let's look at some examples. So our examples here, first one's going to be arc sine of negative 1/2. So you can pause the video, try that out. When is sine equal to negative 1/2? And that will tell you the arc sine of negative 1/2. So if we think back to the unit circle, negative 1/2 is going to be right here. Now, do not give me this as an answer. Do not go this way around and say, oh, we are at 11 pi over 6. It is true that the sine of 11 pi over 6 is negative 1/2, but what's the problem with that? The problem goes back to our restriction. In order to get to 11 pi over 6, I have to go this way into the left half of the circle and then all the way over here. 11 pi over 6 is bigger than pi over 2, and that's the problem. So look at this as a no-fly zone. If we're drawing this in standard position, we have to go through the no-fly zone. That's an issue. Instead, go clockwise and give me the negative coterminal angle to 11 pi over 6. So right here is our initial side, and we're going to go to the coterminal angle to that, which is negative pi over 6. So the arc sine of negative 1/2 is negative pi over 6. Now for our next one, think about it in the same way, arc cosine of root 2 over 2. So if we just sketch a unit circle here, I want to know when is the x value root 2 over 2. Remember with cosine we restrict ourselves to the top half of the circle. Over in here is going to be root 2 over 2. Where is it? It's going to be at a 45-degree angle, isn't it? And so this is at pi over 4. Next, the arc tangent of 0. Remember, with tangent, we're restricting ourselves to the right half, and we're thinking about slope. When is the slope equal to 0? It's equal to it at 0 radians. Not 2 pi, because 2 pi is bigger than pi over 2. So it's going to be at 0. Next, the sine inverse of 2. So when we're looking at our unit circle, we want to know, when is our y value equal to 2? Well, if we go from this, at the bottom is at -1, at the top it's 2. There's no, not 2, it's 1. There's no value here that we can take the sine of something and get 2, because our values bounce between -1 and 1. And so this is no solution. Be careful with those. Sometimes those can be tricky. All right, let's look at another set. The cosine inverse of -1. Let's sketch our unit circle here. And remember, cosine is our x values. We want to know, when is cosine equal to -1? It's going to be right here. And for the restricting cosine, we're going to say it's the top half of the circle, and so we get it right here at pi. So the cosine of pi equals 1. Therefore, the cosine inverse, it equals -1. Therefore, the cosine inverse of -1 is equal to pi. Next, the tan inverse of -1. Draw our unit circle. Remember, tangent is talking about the slopes of the lines. So when is it equal to -1 on the right half? It's going to be right here. And this is going to be -pi/4. Remember, don't go this way like we did with that sine value there. You don't want to tell me 7pi/4, because that's bigger than pi/2. And we're restricting ourselves to just the right half of the circle on tangent. And so this is -pi/4. Why? Because the tangent of -pi/4 equals -1. So therefore, this is my answer. All right, now we get into some funny stuff right here. We're taking the tangent of the arc cosine of 2/3, and 2/3 is not something that we know from what we memorized on the unit circle. So what I'm going to do on a crazy question like this is to actually draw it out. Now with arc cosine, I know that I'm restricting myself to the top half here, and this is 2/3, so I'm actually just going to sketch that point. Cosine is what? It's my adjacent over the hypotenuse. So the adjacent side right here is 2, and the hypotenuse is 3. And so this theta right here makes our, the cosine of this theta gives me 2/3. So whatever the arc cosine is, it takes me back to that theta value. And I want to know what's the tangent of that angle. So I don't really need to know theta. I don't need to figure this out to figure out the tangent of all of that. All I need to know is, what is that opposite side. So I'm going to use our friend Pythagoras here and say 9 is equal to 4 plus x. That's 3 squared is equal to 2 squared plus x squared. This should be a squared there. Subtract 4 from both sides. I get 5 equals x squared, or x equals the square root of 5. This side here is the square root of 5. Tangent is opposite over adjacent, so this becomes root 5/2. Let's try one more like that, because I know sometimes that can be a little bit confusing. Try this one out. The cosine of the arc sine of -3/5. Now remember, sine is restricted to the right half, so I know that yes, sine is negative, so it's going to be down here or down here. Sine is also opposite over hypotenuse, so I've got, that should be an H for hypotenuse. So I've got -3/5. One of these is negative, doesn't have to be the 3. But we can figure out it's the 3 because it's the opposite side. So -3 is the opposite side, and 5 is the hypotenuse. And because we restricted the domain, that tells me it's not going to be this triangle over here, which could also be -3/5. And then I need to figure out this adjacent side. You can use Pythagoras and figure out that it is equal to 4. And so this is the theta that makes the sine -3/5. Now I'm going to take that theta and figure out the cosine. So cosine is adjacent over hypotenuse. So the cosine right here of all this mess, I've ran out of room to write equals, it's going to equal adjacent over hypotenuse, or 4/5. And that's my answer there. All right, I know that you're probably feeling a little like, I need some more examples on that. And so I'm going to give you some more examples. That was just kind of your introduction. We're going to do a ton of examples on these so that you feel super comfortable before you take the quiz or the test. Let me know if you have any questions. Thank you for watching, and keep working hard.